A quick note before the script. I pulled real current research for this one. The actual project is the Earth Species Project's work with crow researchers Vittorio Baglione and Daniela Canestrari in northern Spain, published as recently as May 2026. It's genuinely fascinating, but it's a call classification and pattern detection breakthrough, not a we translated crow into English moment. So I've written it with the same honest framing as your other scripts, assuming 3,200 words to match your Egypt track format. Here it is. Scientists studying a population of wild crows in northern Spain just did something that sounds like science fiction, and turns out to be real, carefully documented, still unfolding science. They didn't teach a crow to speak English. They didn't build a magic translator that spits out subtitles under a bird's beak. What they did was feed years of recorded crow vocalizations into an artificial intelligence system built specifically to find structure in animal communication. And what came back was the first real glimpse into just how complicated a crow's vocal world actually is. More than 127,000 individual calls, sorted, categorized, and cross-referenced against video and movement data, revealing patterns that no human researcher listening by ear could have picked out of that much raw audio in a lifetime. This is the story of what that research actually found, who did it, how AI made it possible, and why the honest version of the story, the one grounded in what scientists have actually published, is more interesting than the exaggerated version currently spreading across the internet. The research center of this story is a small area of farmland and woodland in northern Spain, where two biologists, Vittorio Baglione and Daniela Canestrari, both professors at the University of Leon, have spent decades studying a specific population of carrion crows. Carrion crows are common across Europe, closely related to the American crow many people are more familiar with, and they were chosen for this research for a very specific reason. Unlike most birds, carrion crows in this population practice cooperative breeding. That means when a pair of crows raises chicks, it isn't just mom and dad handling the work. Older siblings, aunts, uncles, and unrelated helper birds all pitch in, defending the nest, feeding chicks that aren't their own, and coordinating group behavior in ways that require an enormous amount of information to pass back and forth between individuals. If you wanted to find a species of bird where sophisticated vocal communication would actually be necessary for survival, rather than just occasionally useful, a cooperatively breeding crow family is close to the ideal case study. Raising a family as a group takes coordination. Coordination, in a species without hands or written language, takes communication. And communication, if it exists at the level these behaviors suggest, ought to leave a signature in the sounds these birds make to each other. For years, Baglione and Canestrari did what field biologists have always done. They deployed audio recorders in the trees and biologgers, small tracking devices, on the birds themselves, then sat down and manually listened through the recordings, trying to link specific calls to specific behaviors. This works, but it is brutally slow. Each microphone in the field only lasted 6 or 7 days before it needed to be retrieved and reset, and every one of those days generated hours of raw audio that had to be picked through by a human ear, trying to catch the difference between a warning call, a contact call, a feeding call, and simple background noise. The two researchers have said plainly that they eventually hit a wall that had nothing to do with the birds and everything to do with the sheer volume of data. There was simply more recorded sound than any team of graduate students could reasonably process by hand in a useful time frame. This is the exact kind of problem that AI pattern recognition was built to solve, and it's the reason this research took the turn it did. Starting in 2024, the team began collaborating with the Earth Species Project, a nonprofit research group based in the United States that specializes in building AI models capable of finding structure in animal communication across many different species, not just one. Instead of a general-purpose AI chatbot being pointed at bird sounds, the Earth Species Project builds specialized machine learning models trained specifically to process bioacoustic data, meaning the actual raw sound patterns animals produce, and to sort those sounds into meaningful categories based on their acoustic properties. Applied to the Spanish crow recordings, this technology did something that would have taken humans months or years to do reliably. It sorted the massive backlog of recorded calls, more than 127,000 of them, into distinct categories, distinguishing between the calls of adult birds and juveniles, separating out crow calls from the calls of other bird species picked up in the background, and identifying when multiple crows were vocalizing back and forth to each other at the same time, something the researchers describe as genuine dialogue occurring between individuals in the same territory. Where the AI system became especially useful was in an unglamorous but critical task, synchronizing recordings from multiple separate microphones and biologgers so that researchers could see exactly which specific bird was calling at exactly which moment, even when several crows were vocalizing within the same few seconds of each other. Untangling overlapping voices like that by ear is exhausting and error-prone. For a machine trained on the acoustic signature of each bird's calls, it's a solvable pattern matching problem. And solving it opened up an entirely new layer of the data that had essentially been invisible before. What the research has found so far, and it's important to say clearly that this work is still ongoing and the scientists themselves describe it as a work in progress rather than a finished decoding, is genuinely intriguing. The most consistent finding to come out of the analysis so far is that the overwhelming majority of crow vocalizations are quiet, soft, low-amplitude murmurs, rather than the loud, sharp caws most people associate with crows when they think of the species at all. That matters more than it might sound like at first, because it suggests that a large share of everyday crow communication isn't built for broadcasting information across a long distance, the way an alarm call warning the whole flock about a predator would need to be. It's built for close range, quiet, intimate exchanges between family members who are near each other, the kind of vocal contact you'd expect between a parent and chick, between siblings coordinating who's watching the nest while the other forages. That's a meaningfully different picture of crow social life than the one most people carry around, which tends to be built entirely around the loud, harsh calls that are easiest for humans to notice and record in the first place. The quiet stuff, the murmuring back and forth that seems to make up most of a crow's actual vocal day, had been almost entirely missed by less systematic observation, simply because it's quiet and doesn't demand human attention the way a sharp alarm call does. The researchers are now working towards something they describe as a semantic map, a combined data set that links the AI-sorted audio calls to video footage and movement data captured by the same biologgers, so that specific call types can eventually be matched to specific behaviors with real statistical confidence. Baglioni has described the goal directly, being able to match a particular call to a particular behavior in a way that gives real, testable indication of what that call's actual function is. That is the honest scientific bar for saying you understand what an animal call means. Not that it sounds a certain way to a human observer, but that its use correlates reliably and repeatedly with a specific, measurable behavioral context, tested across enough recorded instances that it isn't just a coincidence. That work is not finished. The researchers are careful, appropriately careful, not to claim they have built a crow dictionary yet. What they have built is the foundation that a real dictionary would eventually be built on top of. A rigorously sorted, searchable, cross-referenced library of what these birds are actually saying to each other and when, at a scale that simply did not exist before AI models could process audio data this fast. It's worth understanding why this kind of research matters beyond simple curiosity about what a crow is thinking, because the scientists doing it are motivated by something with real stakes. David Robinson, a senior AI research scientist at the Earth Species Project, has pointed to the disconnect between humans and the natural world as a driving reason behind this research, arguing that understanding how other species communicate offers a genuine window into their inner lives and can build real insight into animal behavior that has practical conservation value. This isn't an isolated project either. The same organization and the same underlying AI approach is being applied well beyond crows. At the Raincoast Conservation Foundation in Canada, researchers are using a similar system to analyze the vocalizations of orcas, animals that live in tight social groups and rely on calls to coordinate hunting and movement as a pod. There, the AI's most immediate practical use has been dramatically speeding up the process of simply finding the vocalizations buried inside huge volumes of ocean audio recordings, work that used to require a researcher listening to every single minute of a recording start to finish, and now takes a fraction of that time. One researcher on that project, Valeria Vergara, described data synthesis work that used to take months now taking about an hour, freeing up actual scientists to spend their time doing the interpretive analysis that still requires a trained human mind rather than burning weeks just organizing raw audio into something usable. It's also worth pausing on something Vergara said publicly that applies just as much to the crow research as it does to orcas, because it's the kind of honest caution that tends to get left out of the more sensational headlines about this topic. She has explicitly cautioned against the growing public fascination with the idea that AI is about to let humans directly communicate with animals, some kind of universal translator moment where you speak into a device and a whale or a crow answers back in a way that makes sense to a human listener. Her stated view is that the more meaningful goal is understanding these animals on their own terms, without inserting human conversatio into what is fundamentally a non-human way of exchanging information. That distinction matters enormously for how this crow research should actually be understood. The AI isn't building a bridge for humans and crows to have a conversation. It's building a far more precise instrument for scientists to observe, categorize, and eventually understand a genuinely complex non-human communication system on its own terms, which is a different and in some ways more respectful goal than the flashy "we can now talk to animals" framing that tends to spread faster online. None of this is happening in a vacuum either. It builds on decades of prior research establishing that crows are cognitively in a completely different category from what most people assume when they picture a bird. Corvids, the family that includes crows, ravens, magpies, and jays, have been shown in controlled studies to make and use tools, something long thought to be close to uniquely human, with New Caledonian crows in particular capable of bending wire into hooks to retrieve food from containers, a behavior no one taught them, and that appears to emerge through a mix of instinct and individual problem solving. Crows have also been shown, in research led by the wildlife biologist John Marsluff at the University of Washington, to recognize individual human faces and hold what looks very much like a grudge, remembering specific researchers who trapped and banded them years earlier and scolding those specific people on site while ignoring others entirely, a memory that appears to get passed along and reinforced by other crows in the area, who never had the original bad encounter themselves. Neuroscience has added a physical explanation for why crows are capable of this kind of cognitive sophistication, despite having a brain the size of a walnut. Research measuring neuron density in bird brains, most notably work associated with the neuroscientist Susanna Herculano-Hausel, found that corvid brains pack an extraordinarily high density of neurons into a small physical space, in some cases rivaling the neuron counts found in primates, despite the total brain size being a fraction of the size. A crow's brain is small. It is not, in any meaningful functional sense, simple. All of that context is exactly why the recent AI-assisted communication research lands as more than a cute animal fact. It's a piece of a much larger, well-established scientific picture of crows as genuinely sophisticated social animals, a picture that has been building for decades through tool use experiments, facial recognition studies, and neuron density research, and that AI-driven acoustic analysis is now extending directly into the actual content of how these animals talk to each other. The honest headline isn't that scientists cracked crow language and found something terrifying hidden inside it, which is the kind of framing that tends to circulate in less careful corners of the internet, chasing clicks rather than accuracy. The honest headline is that scientists finally have a tool capable of processing the sheer volume of vocal data these birds produce, and what that tool is revealing, patiently, call by call, is a communication system built mostly around quiet, close-range, family-oriented exchanges, coordinated across cooperative family units that function almost like a small society, one that has been happening in trees above human heads for as long as crows have existed, simply too quiet and too fast for anyone to properly listen to until now. What comes next, according to the researchers themselves, is the harder and slower part of the work, actually linking specific call types to specific confirmed behaviors with enough repeated evidence to say with real confidence what particular sounds mean, and doing the same kind of foundational work across other cooperatively. Breeding bird species, to see how much of this pattern is unique to this one population of Spanish crows versus a broader feature of how intelligent, socially complex birds communicate in general. It is not a finished dictionary. It is the first properly organized library that a dictionary could eventually be built from, assembled not because scientists finally got smart enough to understand crows, but because they finally got a tool fast enough to listen to everything the crows had already been saying all along.